All right, everyone get ready because we are diving deep into logical reasoning in large language models, a survey.
Oh, this paper, it's a fantastic overview of like the whole history of logical reasoning research and how it applies to LLMs today.
And you are in the right place if you're, an AI researcher, ML engineer.
Right.
Anyone who's, deep in the trenches with LLMs, because we're going to break down what's important in a way that's digestible and fun.
Absolutely.
So the big question is, can LLMs really reason logically?
Yeah.
The short answer is they're showing potential, but there are some hurdles.
There are some challenges, for sure.
It's like they can solve logic puzzles, but explaining why their answer is right in a way that would satisfy a logician.
Yeah.
That's still a challenge.
It's a work in progress.
Think of it this way. They might ace a multiple choice logic test, but ask them to write out a formal proof.
Right.
And they'd likely struggle.
Yeah, that's a good analogy.
Researchers are working on this gap, though, using a bunch of different methods.
Yes.
Some are creating specialized data sets to train LLMs.
Yeah.
While others are combining them with symbolic AI systems.
Yeah.
Which is a pretty exciting area.
That's a really hot topic right now.
This field is evolving rapidly, so understanding the current state of logical reasoning and LLMs is super important for anyone working with this tech.
Couldn't agree more.
All right, let's dive in. This paper takes us all the way back to the foundations of logic.
Okay.
We're talking Aristotle, syllogisms, the whole deal.
Yeah, it's fascinating to see how these ideas developed centuries ago are still relevant and are actually shaping the development of cutting-edge AI systems.
It's like we're seeing history repeat itself, but this time with a technological twist.
Exactly. The paper highlights key figures like Leibniz, Boole, and Russell, who paved a way for modern computational logic.
And we can't forget the giants of AI, like John McCarthy.
Right.
Who really brought these ideas into the realm of computer science?
Yeah, his work on knowledge representation and automated theorem proving was foundational. And now in the 21st century, we're seeing the rise of these really interesting neuro-symbolic approaches.
So we've got this rich history of logical reasoning research.
Yeah.
Now let's shift gears and talk about the different types of logical reasoning.
Okay, sure.
This is crucial because it helps us understand how LLMs approach logical problems.
Right.
It's not just about getting the right answer.
Right.
It's about understanding the process.
Exactly.
Okay. So the paper focuses on 4 main types.
Okay.
Deductive, inductive, abductive, and analogical reasoning.
Right.
Let's start with deductive reasoning.
Okay, so deductive reasoning is all about drawing logically certain conclusions based on given premises.
Right.
Like classic if A, then B stuff.
Like if we know all dogs are mammals and Fido is a dog, then we can absolutely deduce that Fido is a mammal.
Exactly. No surprises there.
Yeah.
This type of reasoning is the bedrock of formal logic.
Right.
Super important in fields like math and, of course, computer science.
Okay, next up is inductive reasoning.
Okay.
Here's where things get a bit less certain.
A little bit less certain.
Yeah.
Yeah, think of it like making generalizations based on observations.
Right.
So you see a bunch of white swans and you might conclude that all swans are white.
Until you see a black swan.
Exactly. Exactly.
So inductive reasoning involves dealing with uncertainty.
Right.
Which is a key challenge for LLMs.
A big one.
Now for abductive reasoning.
Okay.
Think of this like a detective solving a case. It's about finding the best explanation for the evidence.
Right. So let's say you hear someone coughing and sneezing.
Okay.
You might guess they have a cold.
Right.
It's about generating hypotheses and picking the most plausible one.
Yeah.
Which can be tricky, especially for an LLM.
Finally, we've got analogical reasoning.
Okay.
This is all about spotting similarities between different situations, different domains, even
like if you know how to ride a bicycle,
Yeah.
you might learn to ride a motorcycle faster.
Right.
You're transferring knowledge based on similarities.
Okay, so we've covered these 4 types of logical reasoning.
Right.
But how do researchers actually test an LLM's abilities in each of these areas?
That's where datasets and benchmarks come in.
Okay.
They're the testing grounds.
Right.
And they can be categorized into 3 main types: rule-based, expert-designed, and exam-based.
Let's unpack these.
Okay.
Starting with rule-based data sets.
All right.
These sound like they're generated automatically, right?
Exactly.
Yeah.
They're created using predefined logical rules,
Okay.
which makes them easily scalable.
Like a program churning out logic problems based on a set of rules.
Yeah, like Clotar, for example.
Okay.
It focuses on inductive reasoning by testing if an LLM can figure out family relationships from short stories.
So like John is Mary's father and Mary is Peter's sister.
Right.
He is John to Peter. Got it.
Exactly.
What about expert designed data sets?
So these are meticulously crafted by, well, experts in logic.
Right.
This means high quality, but they tend to be smaller in scale.
Makes sense.
A prime example here is Folio.
Okay.
It focuses specifically on first-order logic reasoning.
Right.
Which is a tough area, even for human.
So it's a way to see if LLMs can really grasp the nuances of formal logic.
Exactly.
And finally, we have exam-based datasets.
So these use questions from standardized tests, like the LSAT, GMAT, even the Chinese Civil Service exam.
So it's about testing an LLM's ability to solve the kind of logic problems that people face in the real world.
Exactly.
Like LoBi-QA and Recler.
Yeah, those are two popular examples of this type.
Okay, so we got all these datasets ready to go.
Yep.
Now, the paper dives into analyzing how well LLMs perform across the 4 reasoning types.
Right.
What did they find? Were there any surprises?
Well, there were some interesting findings, both positive and negative.
Okay.
It really highlights the current state of LLMs and where we need to go next.
Okay.
Want to start with deductive reasoning?
Absolutely.
Okay.
Let's see how LLMs handle the classic if-then logic.
So they show some pretty impressive results on certain tasks.
Okay.
Especially those involving compositional proofs.
So they can build logical arguments step by step.
Right.
But what are they not so good at?
They struggle with tasks that require extended reasoning.
Okay.
Like proofs with lots of nested steps or hypothetical scenarios.
Mm-hmm.
They also have trouble generalizing to completely new situations.
So they can handle the textbook examples.
Yeah.
But when things get more complex or out of the ordinary, they falter.
Right.
Okay, what about inductive reasoning?
Right.
How do LLMs fare when it comes to making generalizations?
This is where things get trickier.
Okay.
There's evidence they can do some inductive reasoning.
Okay.
But when it's presented in a more abstract, symbolic way, kind of hit a wall.
It's like they're great at spotting patterns in data,
right?
But they haven't quite grasped the underlying principles of inductive logic.
Exactly. They might be able to predict what comes next in a sequence,
right?
But ask them to explain why they made that prediction.
Yeah.
And they'd probably fall short.
Okay, on to inductive reasoning.
Okay.
This is the detective work, right?
Right. And this is where LLMs face some big challenges. They can sometimes come up with plausible explanations, but they struggle with incomplete information.
So if some pieces of the puzzle are missing, they can't fill in the blanks logically.
It's more than that.
Okay.
They often don't consider all the possible explanations.
Right.
They jump to conclusions without exploring alternative hypotheses.
That can be a big problem.
Yeah.
Especially in fields like law or medicine, where accuracy is critical.
Absolutely. You wouldn't want an LLM making a medical diagnosis based on incomplete information without considering all the possibilities.
All right, last but not least, let's talk about analogical reasoning.
Okay.
Can LLMs see those clever connections between different domains?
There's some promising research here.
Okay.
Some LLMs can learn analogical reasoning surprisingly quickly, even approaching human performance in certain cases.
That's impressive.
Yeah.
But is it real analogical reasoning?
Right.
Or are they just using other tricks like memorization?
That's the million-dollar question.
Yeah.
Researchers are still trying to figure out exactly how LLMs are achieving these results.
Okay.
And that brings us to a crucial point.
Right.
How do we even measure an LLM's logical reasoning abilities?
Right, because it's not just about getting the right answer.
Exactly.
It's about understanding how they got there, right?
Exactly. Just looking at accuracy isn't enough.
Yeah.
We need more nuanced metrics that capture things like consistency, generalization, and explainability.
Okay, let's break those down.
Okay.
What do you mean by consistency?
So consistency means getting the same logical conclusion. Even when the problem is phrased differently, but means the same thing logically.
So it's about not being fooled by surface-level changes in wording.
Right.
Okay.
And generalization is about how well an LLM can apply its logic skills to totally new situations or data it hasn't seen before.
It's like, can they take what they've learned and apply it to a different context?
Exactly.
And explainability, that's about transparency, right?
Exactly. We want to be able to see how the LLM arrived at its conclusion, not just what the conclusion is.
Okay.
This is super important for building trust in AI systems.
Especially if those systems are making decisions that affect people's lives.
For sure.
All right, so we've covered a lot of ground here.
Yeah.
We've looked at the history of logical reasoning, the different types, the data sets used to test LLMs.
Yep.
And even the challenges in evaluating their performance.
We've laid the foundation.
Yeah.
And now, in the next part, we'll explore the really exciting stuff.
Okay.
How are researchers actually improving the logical reasoning capabilities of LLMs?
We're talking about the cutting-edge techniques that are pushing the boundaries of what these models can do.
For sure.
Stick around because it's about to get really interesting.
Absolutely. Welcome back. So now we get to dig into how researchers are trying to boost these logical reasoning skills of LLMs.
The paper outlines 4 main strategies.
Yeah.
Data-centric approaches, model-centric approaches, external knowledge utilization.
Right.
And then the fascinating world of neuro-symbolic approaches.
Yeah, let's start with data-centric approaches.
Right.
This is all about giving LLMs a targeted workout, training them on data that specifically emphasizes logical reasoning.
So it's like designing a training regimen for an athlete.
Yeah.
But for logic muscles.
Exactly.
What kind of data sets are we talking about here?
There are 3 main types.
Okay.
Expert-curated, synthetic, and LLM-distilled data sets.
Let's start with expert-curated data sets.
All right.
I'm guessing these are created by, well, experts.
You got it. Experts in logic carefully craft these data sets,
Right.
ensuring high quality and precise logical structures.
Yeah.
One great example is the Folio series.
We touched on Folio earlier.
Right.
It really puts LLMs through the ringer when it comes to formal logic.
Exactly. And that's the point.
Yeah.
By training on these data sets, LLMs can learn to perform more rigorous logical inferences.
Okay, what about synthetic data sets?
Okay.
Are these like artificially generated logic problems?
Precisely.
Yeah.
Algorithms and rules are used to create a vast number of examples.
Okay.
It's like having a logic problem factory.
I could see how that would be useful for training LLMs at scale.
Yeah.
Any standout examples?
Rule Taker is a great one.
Okay.
It uses a 3-phase pipeline to create a data set
Okay.
with diverse logical structures and linguistic variations.
So not just the same problem reworded over and over again.
Exactly. Variety is key here.
Got it.
And finally, we have LLM distilled data sets.
Okay.
This is where things get a bit meta.
LLM distilled? Does that mean one LLM is teaching another LLM?
In a way, yes.
Okay.
Advanced LLMs like GPT-4 are used to generate reasoning chains or provide intermediate steps that can then be used to train other models.
So it's like having a tutor LLM.
Yeah.
Guiding a student LLM through the logical steps.
That's a good way to think about it.
Okay.
Logic Hot and Logic Pro are good examples of this approach.
Okay, so we've covered the data-centric approaches,
Right.
which focus on feeding LLMs the right kind of data.
Right.
Now let's talk about model-centric approaches.
Okay.
What's the core idea here?
Model-centric approaches involve tweaking the LLM itself.
Okay.
Either its internal mechanisms or its decoding strategies.
It's like fine-tuning the engine for optimal logical performance.
Exactly.
What are some of the techniques researchers are using here?
There are 3 main categories.
Okay.
Instruction fine-tuning, reinforcement learning,
Right.
and inference time decoding.
Okay, let's break those down, starting with instruction fine-tuning. Is this about giving the LLM more explicit instructions on how to reason logically?
You got it.
Okay.
Researchers can fine-tune LLMs on specific tasks or data sets
Right.
that emphasize logical reasoning.
Okay.
It's like giving them targeted practice.
So instead of just feeding them data, you're giving them more specific guidance
Right.
on how to approach logical problems.
Exactly.
Like Logicot and Legipt.
Yeah, those are good examples of this approach.
What about reinforcement learning?
Okay.
How does that apply to logical reasoning?
Reinforcement learning is all about training models
Okay.
through rewards and penalties.
Uh-huh.
So in this context, the reward could be based on how accurately an LLM solves a logic puzzle
Right.
or constructs a valid proof.
So if the LLM gets the logic right, it gets a virtual pat on the back.
You could say that.
Okay.
And if it makes a logical error, it gets a virtual slap on the wrist.
I see how that could help guide the LLM towards better reasoning.
Right.
Any notable examples of this approach?
DeepSeek R1 is a groundbreaking example.
Okay.
They used a unique reinforcement learning strategy
Okay.
to achieve some really impressive reasoning capabilities.
What was so special about DeepSeek R1?
It tackled some of the common issues LLMs face,
Okay.
like generating repetitive or overly simplistic responses.
Okay.
It showed that reinforcement learning can push LLMs beyond just memorizing patterns.
That's pretty exciting.
Yeah.
All right, on to inference time decoding.
Okay.
What's this all about?
Inference time decoding involves modifying how the LLM generates its responses
Okay.
during the inference stage without changing the model's parameters.
So instead of retraining the entire model, you're changing how it uses its existing knowledge
Exactly.
to generate outputs.
Exactly.
It's like giving the LLM a set of tools or strategies
Right.
to help it reason more effectively on the fly.
Exactly.
What kind of tools are we talking about?
Methods like GOT and chain of logic
Okay.
use structured reasoning nodes or decomposition-recomposition techniques.
Okay.
to guide the LLM towards more logically sound outputs.
It's like giving the LLM a mental checklist to make sure its reasoning is on point.
That's a good way to put it.
Yeah.
And then there are approaches like meiotic prompting, which encourages the LLM to reason step by step through a series of prompts and responses.
So it's like having a Socratic dialogue with the LLM, guiding it towards a deeper understanding of the problem.
Exactly. It's about simulating a more iterative and refined reasoning process.
Okay, so we got data-centric and model-centric approaches covered.
Right.
What about using external knowledge to enhance an LLM's logical reasoning?
This is a crucial area because LLMs often struggle with logic because they lack real-world knowledge or specialized information.
It's like trying to solve a physics problem without knowing the laws of physics.
Right.
You need that background knowledge.
Precisely.
Right.
Giving LLMs access to external knowledge sources like knowledge graph or curated data sets can significantly boost their reasoning abilities.
So it's like providing them with a reference library.
Yeah.
Or a team of experts to consult with.
That's a great analogy.
Yeah.
One example is LQ'd.
Okay.
It breaks down complex problems into simpler sub-questions.
Okay.
And then uses a knowledge graph to provide the LLM with relevant information.
It's like giving the LLM a research assistant.
Yeah.
To fetch the facts it needs to build a logical argument.
Exactly. And then finally, we come to the exciting realm of neuro-symbolic approaches.
This is where the magic happens, right?
This is where it gets really interesting.
Combining the power of neural networks with the precision of symbolic AI.
Exactly. It's about merging the best of both worlds.
Yeah. But how do you actually bridge these two very different paradigms?
Right.
Neural networks are all about patterns and statistics.
Yeah.
While symbolic AI is all about rules and logic.
Right.
How do you get them to talk to each other?
One common approach is to translate natural language problems into a formal symbolic representation that a logic solver can understand.
So it's like having a translator that can convert between the language of neural networks and the language of symbolic logic.
Precisely.
Okay.
So for instance, LINQ translates natural language into first-order logic expressions and uses an external theorem prover to perform deductive reasoning.
It's like having a separate logic engine that the LLM can call upon when it needs to solve a tough problem.
That's a good way to think about it.
Yeah.
But there are also approaches that integrate the logic solver more directly into the LLM.
So instead of having a separate component, you're building the logical reasoning capabilities right into the neural network itself.
Exactly. Logic Agent, for example, replaces the external solver with an LLM-based reasoning chain that's guided by logical rules.
It's like giving the LLM a built-in logic module.
And LLM Ties takes this a step further, implementing verifiable reasoning directly within the LLM without relying on any external symbolic solver.
That's incredible.
Yeah.
It's like creating an LLM that can think logically from the ground up.
It's a truly fascinating area, and the progress being made is remarkable.
It is.
We're seeing LLMs becoming more and more capable of handling complex logical reasoning tasks, moving beyond simple pattern matching towards a deeper understanding of logical principles.
This is all incredibly exciting.
Yeah.
But let's take a step back for a moment.
Okay.
Why should someone who isn't an AI researcher care about all this?
Right.
What are the real-world implications of this research?
That's a great question.
Yeah.
As LLMs become more integrated into our lives, their ability to reason logically will be crucial for their reliability and trustworthiness.
It's like, if your virtual assistant can't reason logically, how can you trust it to manage your schedule or book your appointments?
Exactly. Logical reasoning is essential for intelligent decision-making, problem solving, and even creative thinking. As LLMs become more sophisticated, their logical reasoning capabilities will be essential for them to truly understand and interact with the world in a meaningful way.
So we're potentially on the cusp of something truly transformative.
I think so.
LLMs that can reason logically, understand our needs, and help us solve complex problems in ways we haven't even imagined yet.
It's an exciting time to be following this field.
It is, and in the next part, we'll explore some of the challenges and open questions that researchers are grappling with as they push the boundaries of logical reasoning in LLMs.
For sure.
Stick around because we'll delve into the trade-offs between robustness and generalization, interpretability and performance, and the need for more rigorous evaluation methods.
Absolutely.
It's going to be a thought-provoking discussion.
Looking forward to it.
Okay, so we've gone through all these incredible techniques to improve LLM logic. But as with any cutting-edge field, there are always challenges, open questions.
Absolutely.
What did this paper highlight as areas where researchers are still working things out.
Well, the paper does a great job of not just celebrating progress, but also acknowledging these open questions and tensions in the field. It encourages critical thinking about the future of logical reasoning in LLMs.
Let's dive into some of those tensions.
Okay.
The paper mentions a trade-off between robustness and generalization.
Right.
What exactly does that mean?
So it's the classic challenge of building systems that are both good at handling unexpected inputs and capable of applying their knowledge to new situations. Think of it like trying to create a logician who's both meticulous and adaptable.
So on one hand, you want the LLM to be robust.
Yeah.
Meaning it can handle a little noise in the data.
Right.
Or slight changes in wording without breaking down logically.
Right.
And at the same time, you want it to be able to generalize.
Right.
Meaning it can take the logical principles it's learned and apply them to brand new problems it hasn't seen before.
Exactly.
That sounds like a tough balancing act.
It is.
Yeah.
LLMs often struggle with either being too sensitive to small variations or too rigid in their application of rules.
It's like the difference between someone who can follow a recipe perfectly but can't adapt if one ingredient is missing.
Right.
Versus someone who's great at improvising in the kitchen but might not always follow the rules of baking.
That's a great analogy. Finding that sweet spot where LLMs can both follow the rules and end them appropriately. When needed. That's key.
Another tension the paper discusses is between interpretability and performance.
Yeah.
Why is there a trade-off there?
This tension gets at the heart of building trust in AI systems.
Okay.
We want LLMs that are good at logical reasoning.
Right.
But we also want to be able to understand how they're reaching their conclusions.
So we want high performance, meaning the LLM gets the right answers.
Right.
But we also want interpretability, meaning we can see the steps it took to get there. Why is that so tricky?
Well, some of the most successful approaches to improving LLM performance, like training them on massive amounts of data, often result in models that are basically black boxes. We can see the input and the output, but the inner workings are a mystery.
So it's like knowing the answer to a math problem, but having no idea how to show your work.
Exactly. And that lack of transparency can be a problem, especially in high-stakes situations.
Like if an LLM is being used to make medical diagnoses or legal decisions, you definitely want to be able to trace its logic and understand how it arrived at its conclusions.
Absolutely. Neuro-symbolic approaches, which we talked about earlier, are promising in this regard because they aim to combine the power of neural networks with the transparency of symbolic reasoning.
But even those approaches have challenges when it comes to scaling them up to handle real-world complexity.
Absolutely. It's an ongoing challenge to find ways to push the boundaries of performance without sacrificing interpretability and accountability.
The paper also brings up the issue of evaluation rigor.
Yes.
What are the concerns there?
As the field advances, we need to make sure our methods for evaluating LLMs keep pace. Relying solely on benchmarks that focus on multiple choice questions or simple accuracy metrics isn't enough anymore.
So it's not just about whether the LLM gets the right answer, but also about how it gets there.
Exactly. And whether its reasoning process is sound.
We need more sophisticated evaluation methods that can truly probe an LLM's understanding of logic, its ability to handle complex arguments, and its consistency in applying those principles.
It's like if you're testing a student's math skills, you wouldn't just give them multiple choice questions. You'd also want to see their work and hear them explain their reasoning.
It's a call for the research community to step up its game and create evaluation methods that are as sophisticated as the LLMs they're trying to assess.
Couldn't agree more.
What are some of the exciting directions for future research that the paper highlighted?
Oh, there are several. One is the development of hybrid architectures that seamlessly blend neural and symbolic approaches. Imagine LLMs that can fluidly move between pattern recognition and formal reasoning, leveraging the strengths of both.
It's like having a brain that can switch between intuition and logic effortlessly, depending on the task at hand.
Exactly. Another area is the development of more robust evaluation frameworks. These frameworks would go beyond simple accuracy and test an LLM's ability to handle adversarial examples, subtle variations in wording, and even logical fallacies.
So it's about making sure the LLM isn't just finding shortcuts or exploiting loopholes in the data, but is truly engaging in genuine logical reasoning.
Exactly.
What else is on the horizon?
Multimodal reasoning is a very exciting direction. This involves training LLMs to reason not just about text, but also images, videos, audio, other forms of data.
So instead of just reading text, the LLM could watch a video, listen to a song, or even interact with the physical world.
Exactly.
And use all that information to make logical inferences.
Exactly. This would open up a whole new world of possibilities for LLMs, allowing them to understand and interact with the world in a much richer and more nuanced way.
So what does this all mean? It sounds like we're on the verge of something truly remarkable.
I think we are.
Yeah.
The progress in this field is undeniable.
It is.
As researchers continue to push the boundaries, we can expect to see even more impressive feats of logical reasoning from LLMs in the near future.
This has been a fantastic deep dive into the world of logical reasoning in LLMs.
It has.
Thanks for joining us.